For this experiment, we're going to use a converging mirror or a concave mirror, and we're going to use a standard optic bench setup to explore the different kinds of images that we can make using a converging mirror. And so basically, just to go over what I have here, is we have a meter stick in the middle here, which is supported by two support stands just to keep it up off the table. I've mounted a converging mirror or concave mirror using a mirror lens support, and that's just basically an aluminum support, and it has a pointer on the bottom so that we can know where we are along the scale on the ruler. And I've actually set that at about 30 centimeters for our start of our experiment. And then we have a candle holder as well, and so that just slips onto the ruler, and it has a pointer as well. And so I'm just going to put that just anywhere. It's at 50 right now, just to get us started. And then finally, I've just placed a scrap piece of paper underneath the candle, because as we proceed, the candle will drip wax, and we really don't want to get that on our desktop. It just makes cleaning up easier at the end of the experiment if you put something underneath. So I'm just going to light the candle, and we'll get things started here. And by moving this candle around, we can form several different images at several different locations in front of the mirror, and then show you how those work. And so what I've already done previous to now is to find the focal length of the mirror, and it actually is 15. So because I have this at 30, 15 would actually be at the 45 mark on my ruler. And so that's the focal length of the mirror. And then the other point we need to know as well is if we come all the way out here to 60, to 60, and 60 is actually the center of curvature for the mirror, or it's 2 times the focal length. So those are 2 key spots that you're going to want to know for the mirrors and lenses that you might be using for these experiments. So we're going to actually start with our candle way out past 2F, out past the center of curvature, and we'll put the candle, we'll just put it at 70. And then in order to find the image, you need to actually use just a paper screen. So I've just got a standard sheet of paper, and the image will be located in front of this mirror, and in this case it's going to be between the mirror and the candle. And so we just simply move our screen, which is the piece of paper, backwards and forwards until we can actually locate. And I blocked the screen there, and so we're just going to bring it forward, and I'm just going to twist the mirror just a little bit so we can see it, and there you have it. And so at that point you can see an image of the candle formed on my screen. Let's zoom in a little bit there, and you can see the candle is back here and the mirror is over here. And so the image is actually smaller than the actual object and inverted, and it's going to be found always in between the mirror and the object when you're out past that center of curvature point. Okay, and taking away that paper, we're going to just reset our candle and everything here. We're going to slide that candle in. So I said the focal length is 15. We're going to bring it into the 60 mark. And so now we're at 2 times the focal length. And so just to show you the setup, we're going to take the piece of paper and try and find the image. And this time the image will be actually formed. I'm going to just turn so I can see the candle somewhere close to the actual object. And so there we go. You can just see that image formed on my screen. Kind of blank. There we go. Blanked out by the candle a little bit, but right at that center of curvature you'll find the image as well, and the image will be inverted again, but this time the image is the same size as the object. And so that's our change. Brought it into 2F, or the center of curvature, find an image of the same size but inverted. Now we move the candle one more time. I'm just going to go to 50, around 50. Let's say 52 is where I've stopped, and again let's see where we can find that image and what effect moving that object has on the image size and characteristics. And so if we move again, now we can see, I'm going to put my screen back up, and as I move backwards from the candle I can get a fairly sharp image right about there. And so you'll see very obviously that the image is larger and that it's still inverted, but now we have a larger image, larger real image of the object that we have in front of our mirror. Okay. And there's really just 2 other points of significance to check out with students. One is to bring that candle then forward all the way to the focal length of the mirror, which in this case is 15 centimeters, or from 30, so I'm at 45. And to now again try and find that image. And as we look at our screen here, you'll notice it actually is not possible to find that image when the object is located at the focal point of the mirror. And we can do some ray diagrams later to explain that, but right now, just to show it, there is no image, real image formed on a screen when you have the candle at the focal point. Okay. Now the last one to look at is you can bring the candle inside the focal point, so we'll bring it into 48, maybe 49. And again, there's no image back here because there isn't a real image formed when we have the candle or the object inside of the focal length. So we look at our paper again, you can see there's no image there being formed. But if we can just turn the camera a little bit here, and let me just bear with me, and if we look into the mirror, we can now see, which is what it's of course is a virtual image, because we can see the image in the mirror now, and that's an image of our object, and it's virtual and it is upright. And so we do have an image, it's just not a real image anymore, and we can no longer find it by using our paper screen. Okay? So those are the major points that you want to try and show students when you're using this optical bench setup to look at concave mirrors. And each one of those, they can play with that and then see the changes that it has. But just in a quick summary there of knowing that where the focal length is, 2 times the focal length, and then being able to put the candles in various spots around those 2 key points will let you demonstrate the various images that are possible with a converging or a concave mirror.